Hello everyone. So today we will be talking about caching in system design. Caching is really important stuff in system designing and while designing really large scale applications. So caching really helps us in storing frequently accessed data in a temporary storage layer. And the most popular examples are memory cached and Redis. So the purpose of caching is to basically reduce latency in lower database load and speed up the application performance. So basically, it acts as an intermediary layer between the user and the primary data source, right? So in system design interviews, caching comes almost every time you need to handle high read data, okay? And what happens is that most of the applications have database, and sometimes the database becomes the bottleneck, and due to which the latency starts creeping up. And what happens is that because of this latency, you don't know that why my application is lagging. So in this situation, you need to implement a strategy where your application becomes faster and it basically have access to your data in without any latency. Okay. So I will give you an example. For example, let's suppose you are using a Postgres database and it takes 50 milliseconds to load data from database to your front end. Obviously, there will be an API, and what happens is that if you use an in-memory cache, for example, Redis, so that time just reduced to 1 milliseconds. And that is kind of a 50 times improvement in latency. Because the database store data on a disk and every query pays the cost of disk access. And on the other side, the cache memory sits much closer to the CPU, and that avoids that entirely. So there is no latency or very less latency. Okay. Now, why we need caches? Because it is really essential for scalable systems, and uh, it almost reduces the load on the database and it dramatically increases the performance of your application. Now, coming to different types of cache, almost a question comes where we have to store our cache. So there are many types, and the first and most popular is the external caching. Okay. So in external caching is basically a standalone cache service in where your application talks to over the network. This is what most people think of when they hear caching. So you store frequently accessed data in something like Redis or Memcache, so you do not have to hit the database every time. Okay, we have a client and it tries to access application servers. So what happens is that first it checks the cache. If the data is available in cache, so it is automatically retrieved from this cache. If it does not exist, then as a fallback, the database is used. Okay. The external caches scale well because every application server can share the same cache. They also support eviction policies like LRU and expiration, where where we specify the time to live, so your memory footprints basically stay in control. Okay. Now, another type of caching is the content delivery network. So it is basically a geographically distributed network of servers that cache content close to like users. Okay. So instead of every request traveling to your original server, the CDN store copies of your content at the edge servers around the world. What it means is that this is our client, okay, and this is the server, okay. So without CDN, what would happen is that this client would access this server. Let's suppose this client locates, this part of the world, and the server is somewhere in America or Australia. So the client would just send a request to this server every time to fetch the data. Okay. So what happens is that because of CDN, we have the frequently accessed data cached near to that client. So instead of every request traveling to your original server, that CDN basically keep copy of your content at its own server. Okay. I will give an example that let's suppose a user requests an image from your app, right? So the request goes to the nearest CDN edge server. If the image is cached there, it is returned immediately. If not, the CDN fetches the image from your origin server. After fetching this, it stores that image in this CDN and then it returns to the user. Okay. And for the future requests, all those users who are near to this CDN get the image instantly from this particular CDN. So this is the beauty of the content delivery network, right? And for example, if this CDN was not available, so every image request would travel to your original server, and that would just add up like latency per request. Okay. So this gives us a massive performance difference if we use CDN in our system architecture. All right. Now the next part is we can have client-side caching. So client-side caching basically stores data close to like the requester to avoid unnecessary network calls. This usually means that you store the data on user's device like browser. By browser, I mean the HTTP cache, local storage, session storage, or if you're using a mobile application, so every mobile has its own local memory or on device storage. So uh, we basically use it as a cache mechanism. So what happens is that once we cache this data on the client, so we have less frequent calls to the application servers, and this means that we won't be hitting the database again and again. So the data is stored on the client in a form of cache. Obviously, you will specify a time to live. So whenever the client needs that data, so it will fetch from its own local cache instead of hitting all the application servers and database again and again, right? The fourth type is in-process caching. And in-process caching is for let's suppose if your service keeps requesting the same small pieces of data again and again. So what happens is that we store them in a local cache inside the process, and then reads from the local memory, and it makes them faster and avoids any network calls, right? So this light form of caching makes sense for small piece of data that are requested frequently. I will give example you have configuration values, feature flags, uh, some sort of small reference data sets, hotkeys, uh, rate limiting counters, or pre-computed values. So what happens is that you can use that memory to cache data directly inside the application process instead of always calling out to Redis or the database. Most of the application servers, if you um, take example of .NET Web API, so it has also in process caching. So you cache the data, as I gave example, and uh, your application performance really boost up, right? Because of this, the application becomes pleasantly fast, and obviously, most of applications have its own cache. There are some limitations, because what happens is that let's suppose this application is deployed on different servers. So all of these servers will have their own cache. So the fallback, or the what we can say is the limitation is that these applications servers won't be having any idea that what kind of values are cached among all the servers. So every application server will have different set of data cached. So this is the limitation of in-process caching, where we have to make sure that all the application servers have the same set of cached data. Okay, so this was pretty much the introduction to caching, and we have discussed the external caching, content delivery network, client-side caching, and in-process caching. In the next video, we will talk about the cache architecture. So I hope you guys have got the basic understanding of how this caching works. And if you guys have any question, please feel free to leave it in the comment section. I will be happy to answer you there. And if you like this video, please give a thumbs up, and also subscribe to my channel and share this with your friends. Thank you so much. Have a nice day.